Hi, welcome to Unit 9B, Day 2. We're going to look at a new word called secants. We're going to continue with tangents, and we're going to look at angle measures in circles. So we need to remember what a tangent is. It's a line that intersects a circle in exactly one point, and it is perpendicular to the radius. Remember, that means it intersects the radius at a 90-degree angle at the point of tangency. The next one is secant, and it's pronounced secant. It's a line that intersects a circle in exactly 2 points. Oops, T-W-O. 2 points. Okay, so 2 points, meaning let's say maybe a point here and maybe a point over here. And then it kind of looks like a chord, except it's going to extend through and outside the circle. So this line is considered a secant line. It intersects the circle in 2 points. A line can either intersect in 1 point, is a tangent, in 2 points is a secant, or it doesn't intersect the circle at all. Those are the only possibilities with lines and circles. Okay? If a secant and a tangent intersect at the point of tangency, the circle will be divided into 2 arcs. The measure of each arc is 2 times the measure of the angle formed on the corresponding side of the intersection. So there's kind of a lot going on with this paragraph. Let's kind of break it down and see what it's talking about. We have a secant and a tangent. So if I look here, I can see I have a secant here. This is my secant. And then I have a tangent that's only touching the circle in one spot. They are intersecting at the point of tangency. So I know my secant's going to have 2 intersections on the circle, but where it intersects the tangent has to be at the point of tangency. Okay? Then my circle is divided into 2 arcs. Okay, divided into 2 arcs. Most of the time, you'll have one arc that is a major arc and is more than half the circle. And then you'll have a second arc that is a minor arc, less than half of the circle. The only time you won't get a major arc and a minor arc at the same time is if this secant includes a diameter. If the secant includes a diameter, then it'll divide that circle exactly in half. And you'll have a semicircle and a semicircle. Okay? So that's what I got from just the first sentence. Okay? The measure of each arc is 2 times the measure of the angle formed on the corresponding side of the intersection. So the arc is twice the angle formed on the corresponding side of the intersection. Let's talk about what that means. Okay? That means if I were to measure one of the angles on either side of the secant, so let's say I put down my protractor and I line it up to where this line is going out towards 0 on the outside. I want to see how big is this angle. This angle is between 110 and 100 degrees. So let's see, it's a little less than 110. It's like about 107 degrees. So this angle in here, this angle right here, is 107 degrees. The arc is going to be twice that. So this is 107 degrees. The arc is 214 degrees. Okay? And then I can do the same thing on the other side. If I were to measure the other side, which I really wouldn't need to, because if this side's 107, together they make this line. So I know that together they should add up to 180. So if I measure around, this time I'm going to this 0, and so I'm looking at the inside numbers, and I can see it's between 75 and 80, and it looks like it is about 73 degrees, which makes sense because I have 107 and 73, and together those angles make up this whole tangent line of 180 degrees. Okay, then I double this to get my arc measure, so that's going to be 146 degrees. When you put together your 214 and your 146, you're going to get to 360 degrees, the whole circle. Okay, so let's look at a couple of examples. All right, when I look at this first one, it says label each arc measure and each angle measure. Okay, so I know if this is 130, when this is 214, if I want to work backwards, I double it to go to the arc. That means I divide it in half to go to the angle. So if this is 130, all I have to do is divide that in half. So when I divide that in half, 130 divided by 2 is 65 degrees. So this angle in here is 65 degrees. And again, all I did was do my 130 divided by 2 to get that 65 degrees, which is this angle right here. Okay, so then I have two options to find either this angle or this arc. I could subtract the 130 from 360. When I do 360 minus 130, I get 230. So that is the arc there. And then if I divide this arc in half, it's going to give me this angle, which will be 115. Then look, if I do my 65 and my 115, I get 10, 7, 8, my 180 degrees for that whole line. Okay? Let's look at the next example. So here we started with an arc, and we found the other two angles and the other arc. Here we're going to start with an angle, and we can find the other angle, and then we'll find the two arcs. I know these two angles together have to make a line, so together they make 180. So if I want to find this angle here, I just need to do 180 minus the 25. 180 minus 25 is 155. So that is the angle here, the little angle here is 155. And now my arcs. My arcs are going to be twice as big as my angles. So if this angle is 125, then this one is twice that, 250 degrees. And this one is going to be twice the 155. Oops, this isn't 155. I was supposed to take away 125, so that's just 55 degrees. And then if I do twice 55, 55 times 2 is 110. I started thinking, how is this angle bigger than the 125? That doesn't make sense. All right, so 55 and 125 make my 180. And then the 250 and the 110 make my 360. Okay? All right, now, one last thing we're going to talk about before we move on is the three different places that two lines can intersect when working with a circle. So if two lines intersect a circle, there's three places they can intersect. They can intersect on the circle, looking like an inscribed angle, or like these that we just did here. They can intersect inside the circle, and it doesn't have to be at the center and creating central angles. It can be anywhere inside the whole circle. Or they could intersect outside the circle. So it can be on, inside, outside. There's no other options. The location of the intersection is what determines how you can find the angles that are formed. And so when we talk about the angles formed, we're going to talk about this angle here, or we're going to be talking about this angle here, or we're going to be talking about this itty bitty little angle in here. Okay? So let's talk about what the formulas are. When it's on the circle, we've already seen what we do when we're on the circle, because we know that this right here that I'm highlighting, if I stopped it at where I intercept the circle, and I come out here and I stop it where I intercept the circle, we've already looked at this inscribed angle, and we already know that the angle is 1/2 this arc measure, right? Same thing up here when we're on the circle. This angle is half the arc. So whether you look like this new situation that we discussed today, or if you look like the old inscribed angles that we did in the previous lessons, we know that when we're on the circle, the angle is going to be 1/2 whatever the intercepted arc is. Okay, 1/2 of this intercepted arc. Okay, if we're inside the circle, it's a little bit different, because if I come out from this angle and on both of these rays, I can see I intercept this arc here. But if I look at the vertical angle, the congruent angle on the other side, it goes out and it intercepts this little arc over here. So there's two intercepted arcs that go to this measure of an angle. So what we do here when we're inside is we do the angle is the average of those two arcs. And since it's two arcs, what we're going to say is it's going to be 1/2, because we're going to divide by 2 because there's two arcs, the sum of the intercepted arcs. Okay, and then my last option is, what if we intersect the circle outside? Okay, if we intersect the circle, or if we intersect outside the circle, so in this case here, we see that as we come out of the angle, again, just like over here I had two arcs, I'm going to have two arcs. I'm going to have this inside arc, and I'm going to have the outside arc. So you can't just average them together like we did over here. There's not just one arc to divide in half. What we do on this one is very similar to the other two, my angle. This time though, it's going to be 1/2. Instead of adding the two intercepted arcs together, we're going to subtract them. So the difference of the intercepted arc. So there's two of them. Okay, so what we need to remember anytime we're working with trying to find angles with an intersection around a circle is, if we're on the edge of the circle, it's 1/2 the intercepted arc. If we're inside the circle, it's 1/2 the sum of the intercepted arcs. And if it's outside the circle, it's 1/2 the difference of the intercepted arcs. In the next video, we'll take a look at applying this process to answer questions about circles and intersections. Thanks so much for watching.